Hey guys, well, as I told you, we are going to go over the questions on page 174 and 175 in your logic book. Um, I know I had assigned these questions quite a while ago, so you should have started them. But anyway, if you want to take them out, um, and I will go over them with you and help you out with them, all right? So make sure you label this as homework for pages 174 and 175. Make sure your name is on it. And the first section is define. So I will let you do that on your own like normal. So that's numbers 1 through 4. And then the next section is explain. So let's take a look at that. Number 1 in explain, or under explain, is it says in the space provided, explain how someone can can structure a valid deductive argument that is false or nonsensical. Illustrate this by writing a nonsensical valid syllogism to illustrate your point. And then it gives you a hint. Write a nonsensical excuse me. Write a nonsensical AAA1 syllogism like the one in the lesson. Okay, so don't use the one in the lesson, but you can follow that pattern, but do something a little different. Anyway, but let's start with the first question. Explain how someone can structure a valid deductive argument that is false or nonsensical. So how can you do that? Um, we talked about this in yesterday's lesson. Do you guys remember? Did you get an answer for this already? If you did, that's great. What did you get? It should be something, your answer should be something to the effect that a syllogism can be valid but false or nonsensical because validity simply refers to whether or not a syllogism is structured correctly, not whether its premises are true or not. Therefore, you can have a syllogism with false premises that is structured in a valid manner. Okay? So, in other words, it can be structured correctly, but if one of your premises is false, then that makes your syllogism false. So, again, think of an obvious example. Um, Something like all cats are dogs. Um, all panthers are cats. Therefore, all panthers are dogs. See how that works? That's a triple A. I think if I said that right, that was a triple A one syllogism, an AAA1 syllogism. Okay, and it's not true. And the reason it's not true is because the first premise, all cats are dogs, is a false premise, is an untrue premise. Okay, it's structured correctly. Okay, it's valid. It's a valid argument, but the premise is false, so that makes the conclusion false, right? So basically, just come up with a simple AAA1 syllogism. Don't use mine, don't use the book, but just come up with a simple AAA1 syllogism and make one of your premises obviously false, and it's going to make your conclusion false, right? Okay? Number 2, in the space provided, explain why it is important to start a deductive argument using a priori premises. Now, this has a lot to do with what we were just talking about in number 1. Um, we have to have premises that are true. And that's what a priori means, right? It's self-evident truths, things that anybody can look at and say, yes, that's true. Um, So, yeah, your answer should be something to the effect of a priori premises are premises that are known to be or people believe to be true. It is important to start with a priori assumptions when arguing deductively, because if you start with falsehood and error, even a valid deductive argument will lead you into more falsehood and error. Okay, so it's very important that your premises are true when you argue deductively, that you use a priori truths, things that everyone believes to be true. Um, Number three, explain what a counterexample is and how it works. So, again, we talked about this yesterday. A counterexample is a syllogism that determines another syllogism's invalidity. In order for a syllogism to be valid, both premises must be true and must lead to a true conclusion. Sometimes, however, you can have a syllogism that has true premises and a true conclusion but is actually invalid. However, if you can construct another syllogism with the schema that has true premises but a false conclusion, then you can show through counterexample that the schema of that syllogism is invalid. So, in other words, if you take any syllogism um, and you can change it, uh, and if you can make two true premises that give you a false conclusion, that means that schema is invalid, right? If in any possible way you can change the syllogism using the same schema, just changing the terms, but using the same schema, and if in with any possible combination of terms, you can make that syllogism have two true premises and a false conclusion, that means that schema is invalid. That's the counterexample method. And that leads us to number four. Explain why counterexamples alone can never demonstrate with 100% certainty the validity of a certain kind of syllogism scheme. And again, basically, the reason for this is because in order to really truly um, be able to use the counterexample method with 100% accuracy, um, you would need every time you use it, you would need to use every possible syllogism in the world, and all it would take is one syllogism that would have two true premises and one false conclusion to render that schema invalid, right? So really, to use this with 100% foolproof accuracy, you would have to use every single possible combination of terms in the world, which is beyond impossible, right? There's no way you're going to do that. So really, the reason it's not a 100% foolproof method for finding validity is because there's just too many options out there. Okay, and its purposefulness is when you can quickly find one easily, when it's not hard to find a counterexample that renders the schema invalid. If you can easily find one, quickly find one, then it's useful. But if you can't, then it becomes completely a waste of time because you're going to spend too much time trying to figure it out, right? So anyway, yeah, so something to the effect that counterexamples alone cannot establish the validity of a certain schema with 100% accuracy because no matter how many counterexamples you attempt to create that end up seemingly verifying a syllogism's validity, you could always construct another one that shows it is invalid. In other words, you would have to construct all the possible syllogisms in the world to demonstrate validity through counterexample alone, which is neither time effective nor actually possible. So something to that effect, right? By the way, feel free to pause the video and rewind it and re-listen to my answers if I'm going too fast. Okay? Um, let's see. Practice. So the next section is practice. The instructions say the following syllogisms are invalid, but their premises and conclusions are true. Identify the mood and figure of each syllogism. Then construct a counterexample that has true premises and false conclusions. Remember, you may have to try several times to find an actual counterexample. So here you get to try it out for yourself, right? So number one says some artists are moody, some actors are moody, therefore some actors are artists. Uh, so what's wrong with a syllogism? It's everything about it seems true, right? So what's the mood? What's the mood? What three-letter combinations do you get from this? And I'm going to give you a little time to figure that out. What is it? Okay. It is an I syllogism. Three I's, right? What's the figure? And again, remember what the figure is? It's the placement of the terms and the premises, right? The combination of your subject and predicate in the premises. And so figure out you can look at your chart. Remember that, the figure chart from previous lessons. If you look at that, you should come out to figure 2, right? So it's an II-2 syllogism. What's a possible counterexample? Did you think of one? Did you think of one that you could put in here using the same mood and figure that turns out, put it this way, that gives you two true premises but a false conclusion? If you did, that's great, and leave the one that you have if you got it. I'm going to give you the example that they have in the book, and then and if you haven't figured one out for yourself yet, you can use that one. But if you did figure one out for yourself, I would like to see it. So leave the one that you have. Okay. The one that they have in the book, the counterexample is a very simple one. Some cats are black. Some dogs are black. Therefore, some dogs are cats. Okay, so that's using the same mood and the same figure, right? Some cats are black is an I statement. Some dogs are black is an I statement. And some dogs are cats is an I statement. Okay, it's a figure 2 because your minor term, do I have that right? Or your middle term is comes in the is the predicate. Sorry, yeah, your middle term is the predicate of both premises. Okay, so the term black is the predicate of both premises. Um, so you have the formation for a figure 2 syllogism. All right, some cats are black. That's true. Some dogs are black. That's true. So you have two true premises. But then if you keep following the same pattern, therefore some dogs are cats, that's not true, right? So you use the same pattern, different terms, same pattern, and you came up with two true premises and a false conclusion. So that means that this is an invalid schema, right? Okay, let's move to number 2. No professional singers are people with severely damaged larynxes. No presidents are people with severely damaged larynxes. Therefore, no presidents are professional singers. Um, okay, so what's the mood of the syllogism? What's the mood? You should have gotten E, 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 right? Three E's. Um, yeah, universal negative, right? What about the figure? What about the figure? Once again, your middle term is the predicate in both premises. Severely damaged, or sorry, people with severely damaged larynxes. So that means that you have a figure two syllogism. Okay, so triple E, E E E, two syllogism. Mood is E E E, figure is two. Got it? All right, so let's make up another one to see if we can prove that this one is not valid. So let's try to make something simple again, okay? So how about let's say no cats are dogs. Let's just keep it simple, right? No cats are dogs. Um, no panthers are dogs. All right? No cats are dogs. No panthers are dogs. Um, so again, we're following the same pattern. It has to be we're using different terms, but it has to be the exact same pattern. No cats are dogs, no panthers are dogs. Therefore, no panthers are cats. Ooh, that's not true, right? So you have two true premises, but a false conclusion, right? No cats are dogs, no panthers are cats. Therefore, no, I'm sorry, I messed it up. No cats are dogs, no panthers are dogs. Therefore, no panthers are cats. So do you see how that works? Now, again, there's a lot of other formations that you could use that would actually work in this schema. But depending on your terms, it's not going to work. Uh, the because panthers come under the category of cats. If we put that in there, with that kind of syllogism, it's not going to work. Anyway, um, did we get it? So no cats are dogs, no panthers are dogs, therefore no panthers are cats. Is an invalid syllogism. Okay, number three. Some conspiracies are things broadcasted over the television. Some bank robberies are things broadcasted over the television. Therefore, all robberies are conspiracies. Okay, so what kind of syllogism do we have here? The mood is what? Some conspiracies are things broadcasted over the television. That would be what kind of statement? It's an I statement. Some bank robberies are things broadcasted over the television. Once again, an I statement. Um, the last one, all bank robberies are conspiracies. That's an A statement, right? So you have I A for your mood. What about your figure? Once again, you have your middle terms in the predicate of your two premises. So that gives you a figure two. Again, another figure two. All three of these are figure two. Um, so can we think of a counterexample here? Should we stick with cats and dogs and stuff like that? Sure, right? That's pretty easy. So let's do that. Let's see if we can figure one out. with cats and dogs and, you know. All right, so let's say something like some cats are panthers. Can we do that? Let me think. Yeah, some cats are panthers. Um, and then let's say something like some animals are panthers. Okay, so far so good. Some cats are panthers. Some animals are panthers. So that means, therefore, all animals are cats. Did I do that right? I think so, yeah. Some cats are panthers. Some animals are panthers. Therefore, all animals are cats. Okay, see how that works? So, once again, we followed the exact same pattern as the syllogism that the book gives, but we changed the terms and we got two true premises but a false conclusion. Okay? Anyway, that's how that works. You guys got it? Um, you're getting there, right? You're getting there. You'll get it. I know it's a little tricky. I wish I could be there to yeah, be there to explain it in person, but we'll get there. Um, that'll be all your homework for today. You don't have any other assignments for today. And yeah, if you still have questions about how this stuff works, we'll try to get it figured out when I get back. All right, you guys take care.